Today our topic is about the IP routing technology. We already know some principle that if the devices belong to the same segment, how to force the traffic out. We will use the devices like the switch, we will use technology like the VLAN principle, something like this. So now if we want to force a message belong to different segment, for example, from 1.1.1.0 to 2.2.2.0 segment, and we will use new devices about the layer 3 devices of the router or maybe layer 3 switch. So how to force a message belong to one segment to another segment? We will use the IP routing table. And we have lots of source type in the table, like the direct routes, static routes, dynamic routes. So this video we will talk something about the basic of IP routing technology and what's the type of the routes, something like this. So if you are interested, please follow me together. This video we will talk something about the IP routing principle. And we already have lots of videos, but maybe focus on the layer 2 technology, like the STP, like VLAN, something like this. But as we know in the real network, maybe lots of message should be forwarded between different IP segments, right? Maybe some maybe some message from the intranet network, like the private network, and they want to visit some outside network, like the public network, something like this. So in this scenario, we will use a new technology. We call it layer 3 routing protocol. And of course, before we talk about the detail, let's have a review of the last video. We still have several practice questions. The first one, which of the following is not the correct priority? Pay attention here, we don't add the value, but this question based on the VRRP. What is not the correct priority of VRRP protocol? And the answer is option D. The correct priority range is from 0 to 255, right? And about the 255 is IP address owner. And we can use a command to change the priority, and the available range is from 1 to 254. But the 255.6, this is not correct. So this is option D. And the second one, what is the default value of the priority of the router in a VIP default group? When we select who is master, who is backup, we will first to compare the priority. And the default value is 100. So if the priority, you don't use a command to change it, maybe we will continue to compare the IP address because the priority value is same. So we will select the bigger IP address to become master. And of course, if you want some devices to be a master, you can direct it to change the priority to let this device's priority is the highest in the network. So the option is C. And then let's see the IP routing technology. We see why we need this technology. Because in our networks, there are many different IP network segments, right? One scenario like the message from private network go to the public network. And then the data need to be forwarded between this segment. And we have to deploy the layer 3 device, include some layer 3 switch, some router, something like this. And these devices, if they can have the capability of routing and also can help us to forward the message between different network segments, all these devices we will call as layer 3 devices. Maybe the more scenario we will see like the router, like layer 3 switch. But also maybe some scenario will still use the firewall and some EG router. So this is the first reason. And if we have the layer 3 device, the next one is the routing information. We say about the layer 3 device can help us to forward a message. And the next one, the question is how to forward a message. Like the layer 2 switch is very easy according to the MAC address table, and then we will forward the message out. Maybe discard, maybe flat, maybe directly forwarded on the special interface, right? And about the layer 3 device, we also need one table. And this table we call it the routing table. And in the routing table, we have lots of routing information. And this routing information will let you know where you can help to forward. This is the destination you can know, and which interface is a correct interface if you want to forward the message to this destination. So it's very important about the routing table and how to build the routing table and how many parameters in the routing table. This is a key point about this video. And then let's see why the routing is needed. Like this topology, if we have two switches, switch 1 and switch 2, and maybe in our network we have a lot of pieces. If they belong to same segment, it's very easy. About the layer 2 switch, we can directly to help to forward the message out. But if they belong to different segment, we still have to forward the message between these different segments and how to work. And if the terminal between different IP segment, then if the PC do the communication, for example, to do the test ping one destination IP address, then the network card of the PC will check the destination IP address is in the same network segment or not. So this is the first judgment of the terminals. If I found the destination IP is same with my IP address, or maybe different IP segment with my IP address, we will have different next step action. Because all the terminals send out the message, we have to do the encapsulation successfully. We have to add the source and destination IP address. It's very easy. If you ping which IP address, this IP address will become your destination IP. And the source IP also is very easy. The terminal will directly get the IP address from your network card. And the next layer, we will add the source MAC address and the destination MAC address, right? Source MAC address also is very easy from your network card. But how to get the destination MAC address? We say the first step that the terminal will to check that the destination IP is in the same network segment or not, because we have to do the translation. How to get the destination MAC address depends on the judgment. What's the different result? If belong to a network segment, they belong to the same network segment, then we will send out the ARP message, right? This is used to get the MAC address information. And about the detailed process, we already talked about in the before video. If you forgot, maybe you can go back to see the detail. And when we send out the ARP, I want to get one MAC address, and this MAC address will directly to become the destination IP address. For example, I will directly ask my destination IP, what's your MAC address? Please tell me. This is a function of the ARP. Because we in the same network segment, so the broadcast ARP request message will be sent to the destination, and we can get the correct MAC address. But pay attention, if they belong to different network segment, the ARP can be used to pass the MAC address of the gateway. So this is a bigger difference. That's why when you do the configuration of your terminal, not only about the IP address, the mask, but the important parameters is the gateway. Because if you want to forward the message between different segments, we need to ask our gateway to help us. Why your gateway can help you? Because the gateway receives a message and the destination MAC address belongs to the gateway. So the gateway will consider, I should de-encapsulate continue and find that you want to forward the message according to the destination IP address, but belong not my interface, but I have the routing information. So this is very important. In this process, if you don't have the gateway for the terminal, PC1 doesn't know which IP address I can send out for the ARP to get the correct MAC address, right? So this one is very important. And within a layer 2 switched network, that means they will belong to the same broadcast domain or maybe belong to the same VLAN. Hosts on different network segments cannot communicate with each other directly. For example, if here PC2 and PC3 want to visit with each other, they belong to different IP segments. The PC2 want to ask some MAC address about the gateway, but because PC2 and PC3 not belong to the same broadcast domain, so this broadcast message cannot be sent out to the gateway. Although the PC3 may be now in this topology, all of them belong to the same VLAN of VLAN 1, PC3 can get the broadcast MAC address from PC2, but PC3 cannot get the reply because PC2 asks my gateway what's your MAC address, right? This IP address is different with PC3. So in this scenario, we at least to deploy the layer 3 function in this topology, then the PC2 and PC3 can communicate with each other. So in this process, we say ARP is very important because about this process, not about layer 2, also about the layer 3, they have to use this protocol. And another one is we also need the layer 3 devices to have the routing information. So later, we will to talk about the detail, what is routing information and how to get the routing information. And then let's say a basic configuration of the topology if we deploy a router on our network. Because about the last PowerPoint, we say if we only have layer 2 switch, they cannot communicate with each other. But here, if we add a router, let's say it's a detailed process. First, the process of receiving a packet from an interface, orating and forwarding it based on the packet's destination IP address. So this is a basic function. First, if like the topology, we have one router. If router now receives a message from the left interface, I will check my table, and this table we call as routing table. And then we will decide to forward the message out or not, and how to take the message to match the routing table entries. We will based on the destination IP address. And this destination IP address means the parameter encapsulates into the packets, right? And the router will select the correct next hop address or maybe outgoing interface and then forward the message based on the routing table. And then we can do the communication with different segments. Then let's see one process. For example, now PC2 want to ping the connection with a PC3, right? And the destination IP address is PC3 IP address 192.168.2.100. And we also maybe encapsulate some application layer message on this packet. And of course, about the layer 2, we also will add the MAC address information. The source MAC address is PC2, and the destination MAC address is the gateway MAC address. Then the message will send to the router, right? According to the message encapsulation, because the destination MAC address is the router. So first layer is the layer 2 switch receive this message. I will directly forward to the router. Then the router will find, according to the destination MAC address, I know that you want to find the destination IP is 192.168.2.100, right? And then I will match this information to the routing table. And I can find a entry. So this one is very important. You can find an entry. If this routing not exist on your routing table, in your routing table, the router will direct it to discard the message. So this is a very big difference with the layer 2 switch. And later, the router can find the entry, and this process we call is routing. And according to the entry information, we can find the correct next hop and the correct outgoing interface. That means if you want to visit the destination of the PC3, this message should be sent out of the right interface. This process we call is data forwarding. Okay, so now this is the basic function of the router. First, when we receive the message, we have to find the correct entry, and according to the entry to force the message out. The process to match the correct entry, this is a process we call is routing. And then according to the entry, we will finally force the message out. This is a data forwarding. Two process. So very important one is how to get the routing table, right? If your routing table is empty, or maybe your routing table is very smaller, maybe only 1 or 2 entries, finally lots of message will be discarded. So very important one is how to make the routing table bigger. This one is very important. And about the routing table, you have to make sure that every entry is correct. If about your entry finally there is a loop, that means the message cannot be sent out. So we will have lots of topic how to make the correct routing table. And then let's say if now we think the router already gets the correct routing information, then how to forward the message out. So we can divide the layer 3 function to become 2 parts. One we call is a control path. This process, the main function is to get the correct routing table. The second one is forwarding plan. If you already get the correct table, how to forward the message as soon as possible and how to forward the message correctly to the destination. And there we also have some principles. First, let's say the direct routing data communication. About the host site, that means if the terminal wants to send out some message, what's the main parameters? First, about the terminal, maybe the upper layer protocol requires sending the data packets, right? For example, we will do some network testing. On the DOS, on your terminal site, maybe you use a command ping 192.168.1.200, and then you will click the enter button. Then this process we call the upper layer protocol, ICMP protocol, requires sending a ICMP message out to test the network connection. Then about your terminal, we'll do the judgment whether the destination is directly connected or not. What's the different result if we find the destination is directly connected or not? And about the terminal, direct routing means communication with the same IP network. So if the network number and the destination address is the same as the network of the host and the next hop, that means the destination is in the direct connected network segment. So later I will show you some examples. And if we find that my IP address is same with the destination IP address, that means we within the directly connected, choose yes. We will direct it to use the ARP protocol to reserve the destination host hardware address. Otherwise, we will want to get the gateway address or maybe next hop hardware address. Lots of scenarios, the hardware address is a MAC address, right? And if this process, all the terminals, when they do the encapsulation, add the source and destination MAC address, they will have this judgment and use the ARP protocol to get the correct MAC address. If this device is terminal, and we find that the destination IP address is not directly connected, we want to ask the gateway hardware MAC address. If this device is a router or layer 3 switch, we were to ask the next hop hardware MAC address. So these are two processes. And later, if we can get the MAC address successfully, then we can encapsulate into a frame sent out by the corresponding interface. So this is the whole process. So how to have the judgment that we say we in the same segment or not, because this one is very important, right? And the first one, we have our self IP address, and we also have the mask. And then when we send out the destination IP address, and we have to take my mask and find the network part is same or not. If the network address is same, that means we are in the same IP segment. We are directly connected with each other. So like the first example, if my IP address is 10.1.1.1, the mask is 8, and the destination IP address is 10.2.1.1. The mask 8, that means if our first 8 bits is same, we are in the same segment. And the first 8 bits is 10, we are same. So about these two IP addresses, they are in the same segment. If another one, the IP address is 172.16.1.1, the mask is 16, and another one is 172.16.2.1, we have to compare the first 16 bits, these two parts. We will find the value also is same. So they also in the same segment. And the third one, if the mask is 24 and the IP address is 192.168.1.1, and we will compare the first 24 bits, we will find these two parts are different. So in this scenario, these two IP addresses are not in the same segment. So this process is very important. And later, let's see the direct routing communication with each other, see the detailed process if PC2 want to ping with PC3 successfully. The communication with PC1 and PC2. PC1 and PC2, they are in the same segment. On the PC1, you can directly use the command ping 192.168.1.200. And this is a command we will add on the PC2, and later the PC1 will do the encapsulation. The source IP address is 192.168.1.100. Destination IP is 192.168.1.200. Destination IP address from the ping, right? And the source MAC address is very easy. This is a MAC address of PC1, but we lost the destination MAC address. So how to get the destination MAC address? We have to send out the ARP request message. And this is ARP request, and the type is broadcast message. And the sender MAC address, sender IP, target MAC address, target IP. This you can say is the application message of the ARP protocol. And ARP message, you can think this belongs to the layer 2 protocol. And the source MAC address is PC1 and the destination MAC address OF, because this is a broadcast message, right? And this message will be broadcast sent to the layer 2 switch. And once the layer 2 switch receives this message, because this is a broadcast message, so I will do the flood. I will send to the router on this topology about the left one. I also will send the message to PC2. And when PC2 receives it according to the target IP, I know that now this message's function is I want to know the IP address 192.168.1.200. What's your MAC address? Please tell me. This is the ARP request function. And PC2 will find my IP address is same with the ARP request message target IP. So I will give a reply. And this reply message is a unicast message. And in this ARP reply message, I will tell you my MAC address is MAC address-PC2. So after we receive the ARP message from the PC1, later I can get the information. I can get the correct MAC address from the PC2. It's MAC address PC2. Then I can send the correct message out. Right, because according to the ARP request and the ARP reply message, I can find the destination MAC address is correct of the PC2. So later, I can directly send the ICMP message successfully. So this process is very easy. PC1 and PC2 in the same IP segment because according to the /24, the mask 24, PC1 and PC2, the network part address is same. So this is a direct route. But about the router, how to forward the unicast IP message? That means about the terminal, maybe they belong to the different IP segment. So in this scenario, we need the router to help us forward the message out. And let's see the detailed process. First, if the router inbound direction receives a message, I will check the destination IP is native or not. What means the destination IP is native? When I receive the message, first step, the destination MAC address must be one router interface, right? Otherwise, the router will directly to discard the message. When I receive the message according to the layer 3 MAC address, I will find I have to do the de-encapsulation continue. So I will delete the source MAC and destination MAC information. And then I will check the layer 3 information. The destination IP is native or not. Native means the destination IP address is one IP address of my interface. If yes, I will directly submit native upper layer protocol to process. For example, someone telnet one router, right? And the telnet IP address is the IP address of this router. So when I receive this message from the terminal or maybe from the other network device, I will continue to delete the destination IP address and the source IP address and continue to let the upper layer protocol. If, for example, if this one is a telnet protocol, I will let the TCP process to do the next action. So this is the first scenario. The second scenario, if we find the destination IP address is not the native, for example, PC1 to send the message to PC2 and the router only is used to help to force the message out, not to deal with to de-encapsulation the message one layer and the next layer or the third layer. The router only needs to force the message out. So when I receive this message, I also will delete the layer 2 information like the source MAC address and the destination MAC address. Then I will take the destination IP address. We also can call this destination IP address is a purpose IP. I will take the destination IP address to match the routing table. And of course, in some scenario, the destination IP address is in the directly connected with one router interface. That means I will directly to reserve the destination host hardware. That means this router is the last network devices of the message. And if PC1 wants to send the message to PC2, PC2 is directly to connect with the router. So in this scenario, I will directly send out the ARP message to ask the destination IP address. What's your MAC address? Please tell me. Otherwise, if the destination IP address is not directly connected with the interface of router, I will continue to send out the ARP message to ask the next hop router hardware.
That's why later I will show you your IP routing table. The next hop parameter is very important. If you give the wrong next hop, maybe finally you cannot force the message out successfully. So after we get the MAC address information, we will do the encapsulation into a frame again. And about this process, we will continue to keep the source IP and the destination IP according to the origin information. About this part, we will not change. But about the layer 2 MAC address, this one will be changed. The source MAC address will be changed to become the interface of the router. And the destination MAC address will be changed according to the ARP protocol. So when you use the router to forward the message, about the message from the source terminal to the destination terminal, in the whole process, the source IP and the destination IP address will be not changed because this one is the parameter we have to forward it to one hop to the next hop, hop by hop. But the destination IP MAC address will be changed. Of course, includes the source MAC address. Between different link, the source and the destination MAC address will be changed according to the link information. Of course, except your network scenario. We say only according to the original different IP segment communication. So in this process, if the network number of the destination address is the same as the network number of any interface of the router, we call the destination is located in the network segment directly connect to the corresponding interface. Of course, about ourselves, we only need to give the correct IP address and to give some static routing and or maybe some dynamic routing protocol to let the router get the correct routing table. It's enough. How to do the judgment, we in the same segment or not? How to send the ARP message and to get the correct MAC address? This one all the devices will do automatically. We don't need to add any configuration. But your function is to give the correct routing table. Okay. So this is a basic process if the router helped us to forward the unicast message. And later, the key point about the router determines the address of the next hop router by looking up the routing information. So the routing information is very important of the layer 3 or maybe layer 3 switch or maybe router. It's very important parameters. And later I will show you an example. Now if we have to provide the non-direct connection routing of data communication, like this router, now the process is PC2 want to ping the destination 192.168.2.100. This is the IP address of PC3, right? According to this topology, PC2 and PC3 within different IP segments. Let's see the process. First, about the PC2, when we add the command ping 192.168.2.100, the first step is we will do the judgment. And according to my IP address and mask, then we will find the destination IP address is not in the same IP segment with the PC2 itself, right? Then we will do the encapsulation. Of course, before we do the encapsulation of the full ICMP packets, we will send out the ARP message to ask the correct destination MAC address. Of course, in this scenario, the destination MAC address should be the gateway MAC address. So, in this PowerPoint, we skip the process of ARP, but the first step, we will send out the ARP request to get the gateway MAC address, okay? And later, after we get the correct MAC address, we will do the encapsulation of ICMP. And about the ICMP protocol, source IP is IP address of PC2, destination IP address is PC3 according to the ping command. And the source MAC address is PC2. The destination MAC address is a gateway MAC address of the router gigabit 0/1. This information from the ARP request. And then this message will be sent out to switch 1. When switch 1 receives this one, we will forward the message according to the MAC address table and only send this information to router interface, not about the PC1, because this ICMP message also is a unicast message. Then the router will receive it. The function of the router is we will receive this message and we will de-encapsulate the IP packets, delete the source MAC address, delete the destination MAC address. Then we will find this message want to find the destination is 192.168.2.100. And then we will take this destination IP address to match the IP routing table of the router. And the router will find the routing information because we have direct routes. Later we will tell you what means direct routes, what means static, something like this. But according to this topology, we can find about the PC3 is directly connected with the router, right? And pay attention this description. I mean directly connect with router means the IP address of router gigabit 0/2, the IP address is same segment with PC3. This one we call is directly connected with router, although in this topology between PC3 and router there is a switch 2. But about switch 2 only provides a layer 2 information, layer 2 function. So according to the routing table, we call PC3 and the interface of router within the same IP segment is directly connected with each other. So about this process, please know it. I mean the logical IP segment, not about the physical link. Okay? So we can find now the destination IP is directly connected with my interface. So I also will send out the ARP message out to PC3. Please tell me what's your MAC address, right? And after get the correct MAC address of the PC3, I will do the re-encapsulate the message again. And pay attention about this re-encapsulation message of ICMP. We will find the source IP and the destination IP also is same from the PC2, right? But the MAC address is changed. The source MAC address will become the MAC address of router interface gigabit 02, and the destination MAC address from PC3. Also because we send out the ARP message to PC3 and PC3 give us a reply. And then this message will continue sent to switch 2 and switch 2 get it, I will give a reply. So this is the main process. And when switch 2 receives this message according to the destination MAC address, I can directly send the message to PC3, not to PC4. And because PC3 receives this message, we will find the destination MAC address is same with my site MAC address. So I will continue to delete to do the de-encapsulation. And I will find the destination IP address also is same with my site. I will delete the layer 3 header information, and then I will find this is ICMP message, and the next step I will give a reply about the ICMP to tell you that I already received this ICMP equal message from your site, and now I will give you a reply. Finally, we will find the result. The network connection is ready. So this is the whole process. If in your network maybe it's more complex, right? Not only one router, we will have several layer 3 devices. And in each layer 3 network, we will do the same process like the router. I will receive the message from the terminal and do the de-encapsulation, delete the layer 2 header according to the destination IP address, match the IP routing table, and finally to find the correct next hop, right? So this is the main process of non-direct connection routing information. So in this step, the very important one, if the router wants to help us to forward the message successfully, we need the correct IP routing table. So the next video we will talk about the detail. What makes the IP routing table? How to make the IP routing table correctly, and what different source can become the routing entry and then add into the IP routing table. If you want to know some detail, please follow the next video.